Guys, welcome back. So in this video, I'm going to go over AMC 10B Fall 2021, problems 17 and 18. Now I'm going to tell you these two problems are a lot. They are, like, I was just working them through just to kind of make sure I'm ready, and whew, I got about 3 full pages of just a lot of work. So that's why, even doing 2 problems per video is, I don't know, this one might be a longer one. All right, anyway, let's just get it done. Okay, so this problem says distinct lines L and M lie on the XY plane. They intersect at the origin. Point P -1, 4 is reflected about line L to point P prime, and then P prime is reflected about line M to point P double prime. The equation of line L is 5x minus y is 0, and the coordinates of P double prime are 4, 1. What is the equation of line M? Okay. This problem is all about perpendicular bisectors and midpoints, and doing a whole lot of kind of annoying arithmetic with annoying fractions without a calculator. That's pretty much what this problem is. So we have 2 lines that go through the origin, meet in the origin, right? So we know line L has equation 5x minus y 0, or y equals 5x. So we can just kind of draw the line y equals 5x, right? Which we know how that looks, right? Now we have the point -1, 4, right? -1, 4, which would be maybe about here-ish, right? So we'll say that's the point -1, 4, and that point is going to get reflected over line L, right? Which is going to, wait, sorry, I just want to double check something really quick. Yeah, okay. So that point's going to get reflected over that line to some point, maybe over here somewhere, right? And in such a way that this is perpendicular and also bisects, right? So we need to find what's called the perpendicular bisector. So what we can do is we can essentially try to find the equation of this line, call it maybe L2 or L prime or whatever, right? So I'm going to use what's called point slope formula, which is y minus y1 equals m times x minus x1. So a lot of these things are like things you should learn maybe in algebra 2, pre-calculus, right? If these are things you need to brush up on, I'm sure there's tons of videos about point slope formula or point gradient formula. Just find a quick video to brush up on. It basically just comes from the slope formula, right? M equals y2 minus y1 over x2 minus x1. But if you just let x2 and x1 be any random point on the line, then they're just x and y, right? And that's where this comes from. So because we know the line is perpendicular, it has to have a slope that's opposite reciprocal, right? The opposite reciprocal of 5 is -1 over 5. So we're going to do y minus 4 equals -1 over 5, x minus -1. And that's going to give us y minus 4 equals -1 over 5, x plus 1. Or y minus 4 equals -1/5, x minus 1/5. Which if we kind of simplify this, we get y equals -1/5 x plus 19 over 5. Right? Because it's 4 minus 1/5, which is 4/25 minus 1/5, which would be 19/5, right? Yeah. So that's the equation of the perpendicular bisector, right? So what we want to do is we want to find the point where these 2 lines would intersect, right? Which will give us this sort of intersection point here. Whoops. It'll give us this intersection point here, which we'll treat as being the midpoint, right? And then that'll allow us to use midpoint formula to find the point P prime and blah, blah, blah. Okay, so we want to know, where does this line intersect with the red line, right? So -1 over 5x plus 19 over 5 equals 5x. So this ends up giving us So if you simplify this, you get 26 over 5x equals 19 over 5x. Oh, no, sorry. Equals 19 over 5, which basically means x is 19 over 26, right? So x is 19 over 26. Okay, so we know that's 19 over 26. And then the y value is going to be 5 times that, right? Which is 95 over 26, right? So what that means is that's the midpoint, 19 over 26, 95 over 26, is the midpoint of negative 1, 4, and then I'll call this point over here AB, right? And then we'll use midpoint formula by saying A plus negative 1 over 2 equals 19 over 26, and B plus 4 over 2 equals 95 over 26, which tells us A is equal to 32 over 13. And, I'll just leave it to you to do all this arithmetic. I think it's a little boring to show where it all comes from. Remember, you can't use a calculator, so you just have to do your best with it. Hopefully you don't make any mistakes. So I'm just erasing just to give myself more room as I go, but you guys can always rewind if you need to. So now I know the point P double prime is going to be that, right? It's going to be 32 over 13, comma 43 over 13, right? Now that point is going to get reflected, right? So this is what P, this is going to be P prime, and that's going to be 32 over 13, comma 43 over 13. That point's going to get reflected over line M to become the point 4, 1, right? So that's going to get reflected to be like up here somewhere, maybe like here-ish, right? So that means that like the line is going to have to maybe kind of be something like this, right? It's going to be like sort of a low sloping line. Right? So that's going to be what the point, the line M. So we need to, and this is going to be what, 4, 1, right? So we need to find the midpoint of 4, 1 and 32 over 13, 43 over 13. So we would do 4 plus 32 over 13 over 2, comma 1 plus 43 over 13 over 2. Simplifying these results in 84 over 26, comma 56 over 26, which reduces to 42 over 13, 28 over 13, right? 42 over 13, 28 over 13, right? That's going to be our midpoint. And remember, since this line goes through the origin, this will just give us the slope, right? So the slope will just be what? 28 over 14, right? Which can both be divided by 7 to give you, oh, wait, what? Oh, not 28 over 42, sorry. 28 over 42, right? And 28 over 42 both can be divided by 7 to give you 4 over 6 or 2 over 3. So the line we're looking for is the line y equals 2/3 x, right? That's basically the line M, right? Now, but looking at the answer choices, those are not there. But notice how we can write that as 3y equals 2x. And if 3y equals 2x, then 2x minus 3y must equal 0. So the answer is choice D. Ugh, I hate, well, I don't know. I'm not a big fan of that problem. It's not super fun. It's just kind of a lot of annoying fractions. I'm not a big fan of fractions, so any problem that requires me to have to do all this like annoying arithmetic is like not super fun in my opinion, but it's okay. It's just honestly more tedious than difficult, I think. I don't think that problem is particularly hard. It's just like a lot of work, you know. Whew, now this one, okay. This one, we're gonna be here a while, okay? This one, I actually like this one, to be honest with you. I just love geometry, and I love kind of the puzzle solving aspect of a problem like this. I think it's kind of fun to fill in the pieces, you know. But this problem is a lot. It was like two or three full pages of work just to kind of get the answer, right? 3 identical square sheets of paper, each with side length 6, are stacked on top of each other. The middle sheet is rotated clockwise 30 degrees about its center, and the top sheet is rotated clockwise 60% about its 60 degrees about its center, resulting in a 24-sided polygon shown in the figure below. The area of the polygon can be expressed in the form a minus b square root c, where a, b, and c are positive integers. C is not divisible by the square of any prime. What is a plus b plus c? Whew. All right, let's get her done. All right, so let me walk you through what I did, my thought process here, right? So what we know is that each of these side lengths is 6, right? So I know like this whole side length here is 6, and this whole side length is 6, and this whole side length is 6, and this whole side length is 6, right? So what I did was, using sort of some symmetry, I called this sort of length here k, which meant that this is equal to k, which means this is equal to k, which means this is equal to k, right? Which means this sort of little piece in here would be equal to 6 minus 2k, right? Now, one thing you have to notice is that we took this sort of square sheet, we rotated it 30 degrees to get the second sheet, right? Which basically means that this angle in here is 30 degrees, right? Which means this angle is 60, which means this angle is 60, which means this angle is 90, which means this angle is 30. No, sorry, that angle is 60. Right? This angle is 60. Yeah, so this is 60, 60, 90, 60, 60. This is 30, 30, 30, 120, 120, 30, 30. Right? I just like to fill in some of the missing angles. Just it helps me to kind of think about what this would be, right? Now, let's think about it. So knowing the 30, 60, 90 right triangle is like key to solving this problem. So knowing that, like, if this distance is k, this would be k root 3, and this would be 2k. So that tells us that this distance here, this hypotenuse of like you know, this triangle here, right, is 2k, because the 30-degree side is k, so then the orange piece must be 2k, right? Remember, this whole thing here is 6 minus 2k, so then that means that this little piece over here is equal to 6 minus 2k minus 2k, which would be 6 minus 4k. So this piece here is 6 minus 4k, this yellow piece, right? So I'm going to kind of write that here, 6 minus 4k, right? But then also notice that 6 minus 4k. K root 3. So now what if we look at this this triangle here, right? So what do we know? Sorry, I just need a second to look at my notes. So if I know that that's that's 2k, and then oh yeah, and then I know, like, okay, so if this piece here is 6, so remember I said like how the yellow piece here, like this little yellow piece, right, is 6 minus 4k. Well, remember, there's symmetry here, so this is also 6 minus 4k, right? So this little distance here is 6 minus 4k, right? But remember that, like, if I drop a little altitude here, like if I look at this little right triangle here, right, and then this angle is 60, and this angle's 30. Oh no, sorry, this angle's 30. Sorry, this little angle in here is 30, and this angle up here is 60, right? And then this is 6 minus 4k. So then that means that like this height here, like this red height would be 3 minus 2k, right? I'll kind of write it up here because there's not a lot of room. And then that means that like this piece here must be 3 minus 2k square root 3, right? Which means this piece over here is also 3 minus 2k root 3. So now what I can do is I can start adding these things together. So I have k, but I also have another k, so that's 2k. Here, I'm going to try to use different colors so you can see what I'm talking about. So the blue parts are k, right? That was what I started with. So that's 2k. Sorry, I know how messy this is. I'm sorry. Plus the yellow pieces, right? But we said the yellow pieces are 6 minus 4k, right? So 2 times 6 minus 4k, right? Plus, and then the red pieces are each 3 minus 2k times square root of 3. So 2 times 3 minus 2k square root 3. And that has to sum to 6, right? So I'm going to kind of move this over a little bit so I can try to have a little bit. Oh, that didn't really help me. Here, I'll make this smaller so I can. I'm gonna erase this because we kind of already know this. So, and then I'm gonna move this up. There's gonna be like a lot of arithmetic I have to do. So if I kind of simplify this, right, what do I get? I get 2k plus 12 minus 8k plus 6 root 3 minus 4 root 3k equals 6. So then if I solve that, I'm gonna kind of skip some algebra for you because it's kind of, I don't have a lot of room. So if you solve this, you get k equals 6 plus 6 root 3 over 6 plus 4 root 3, which if you do the whole like multiply by the conjugate thing, you know, like this whole mess, you basically end up getting 3 minus root 3. Like, it's, you have to like simplify, but I'm just getting straight to the point because again, I don't have a lot of room, and I think it's boring to just watch all the arithmetic, but at least and you can show the steps yourself, right? So now we know that k is equal to 3 minus root 3. So I'm going to erase this. So if you want to look at this again, you can rewind or take a screenshot or whatever. So now we know k is 3 minus root 3, and now we're pretty good, right? So, okay, now I'm going to actually kind of clear all this stuff up here just because it's got a little messy, and I want to be able to show what I'm doing here. So, now what I just need to do is find the area of one of these sort of, I call it like to me, it looks kind of like a crown, right? This like crown looking thing, right? So I need to find the area of one of these thingies, right? Now, if you think about it, what I could do is I could do like the area of this triangle plus the area of this triangle minus the area of this triangle because it gets double counted, right? And remember, these are 90 degrees, right? And what do we know? We know that this is 3 minus root 3 because it's k, right? We said that this was k and k, right? So that's 3 minus root 3. And remember, this angle was what? 30. 60, right? So this angle is 60, right? Which means that this is 3 minus root 3 square root 2. I mean times square root of 3, right? Which is 3 root 3 minus 3. So it's 3 minus root 3 times 3 root 3 minus 3 half, right? Remember, we're multiplying it by 2 because we have 2 of that triangle. So times 2 minus 1/2, and then I just need the area of this. Now, if I think about that thing, like remember how this height here, if you rewind a little bit, I already found it. It was 3 minus, it was 3 minus 2k. Yeah, because remember this was 6 minus 4k, so this is 3 minus 2k, right? So it's 1/2 3 minus 2k times the base. Now the base was 3 minus 2k root 3, but that was just half of it, so times 2. So 6 minus 4k root 3. right? But remember, k is 3 minus root 3. So here, I'm going to try to work in here. I just have so little room to work with. And also not having a stylus, it's like really hard to write small, you know? So, okay, so if I do that, I'm gonna have 3, okay, let's kind of work out the algebra. So we're gonna, the 2.5 will cancel out, right? 9 root 3 minus 9 minus 9 plus 3 root 3, right? And now we need to figure out this part. But remember, k is 3 minus root 3. So we have minus 1/2 times 3 minus, and then it's going to be 6 plus 2 root 3, because it's, right, times, because it's 2k and k is that, right, times, and then 6 minus 12 plus my brain, so 12 plus 4 root 3, right? 12 plus 4 root 3 right? So it's going to be minus 1/2. I'm just kind of working on this part right now. Like this part I can figure out later. So it's going to be minus what? Negative 3 plus 2 root 3 times negative 6 plus 4 root 3, which is going to be, now I'll distribute out. Now, if I multiply the half by this, it just becomes basically that. So it's like 3 minus 2 root 3 squared root 3. So that's going to be what? 9 minus 12 root 3 plus 4 times 3 is 12, right? Times root 3. So that's going to give me 18. Oh, no. 21. 21 root 3 minus 36, right? So I get 21 root 3 minus 36, and I'm subtracting that. So I'm subtracting this from this, right? So if I simplify that part, I'm going to erase over here to make myself more room. So if I simplify that part, right, I'm going to have what? 12 root 3 minus 18 minus 21 root 3 plus 36. Oh, plus 36. Which is going to give me 18 minus 9 root 3, right? Remember, we have 4 of these things, right? We have 4 of them, right? 1, 2, 3, 4, right? So times 4. So that gives me what? 72 minus 36 root 3 plus the area of the square, the original square, which is 36. So if I add these together, I get 108 minus 36 root 3. So that's A, B, C. A plus B plus C. 108 plus 36 plus 3 is 147, and that's our answer. Woo. Wow. And I mean, I can't imagine that there's any like easy, quick way to do this problem. Like I mean, maybe there is, and I would love if you guys could show me a better way to do it. But to me, it's just like, wow, that problem is just a lot. Like those 2 problems were just a lot, right? Compared to like earlier ones. And like this was just 2 problems in one video. And I'm sure this video is much longer than my last one. So, all right, whew, that was a lot. Yep, right. So sometimes the problems are just tedious, but at least we got through it. All right, so please leave me any comments about maybe how you did it or anything you'd like to tell me. All right, see you guys in the next video.